Okay, so variation caused by meiosis. There are three ways in which meiosis can increase the amount of variation, and it's all to do with the possible combinations of gametes that are produced. Okay, the first mechanism is independent assortment. The second mechanism is called crossing over of the two diagrams there, and the third mechanism is called random fertilisation. And I'll scoot through each one quickly. We've talked about independent assortment in a separate video. Here is an example of how the different ways in which homologous chromosomes align themselves on the equator during meiosis 1 leads to different combinations of gametes. If you can see in this top diagram, there is a different combination. They've arranged themselves differently. We have got two, let's call red maternal and blue paternal chromosomes. Here we have both maternal and paternal chromosomes together, whereas down here there's a different meiotic division. They've arranged themselves differently in that first lining up on the spindle, and this has led to a paternal and maternal chromosome A and B, which has led to different combinations of alleles. So it's all about how independent assortment causes different combinations of gametes to be produced. Crossing over is the second mechanism for variation, and it is all to do with, again, the concept that homologous chromosomes come in contact with each other during meiosis 1. And I like this diagram because it shows us a more true to life version of what's going on. You often see the chromosomes looking like this, whereas in reality during the whole cell division they come into very close contact with each other. They're wrapped around each other, and this leads to them meeting at certain points, and these points are called chiasmata. And at the chiasmata, as you can see here, actual sections of chromosomes swap. Here I'm trying to show that the maternal and paternal bottoms of these chromosomes have actually swapped over. Now this will lead to clearly what would have originally been all paternal chromatids. This chromatid now is paternal, but this one has mainly paternal alleles but a slight bit of maternal alleles. This will then lead to, as shown on this diagram, what would have been two of the same gametes. They would have been, before crossing over, both paternal chromatids. There is now a full paternal chromatid and a new combination of alleles, both paternal and maternal. So that's variation on new combinations of alleles caused by crossing over. And finally, when we create all these new gametes, and these are all the possible gametes that can be produced through independent assortment of an organism that only has 6 chromosomes, these are all the different possible combinations of gametes. You've got to imagine that fertilisation has still got to occur here, and that any one of these two gametes can come together to form the first zygote. It could be that this gamete joins with this gamete, and that will give a different combination of alleles to this gamete joining with this gamete. So this is the random fertilisation, which refers to the fact that there are various combinations of gametes and that the likely ones that will fuse together is completely random. Those three concepts, random fertilisation, crossing over and independent assortment, are why meiosis causes variation.